let's try this again. So this is the interactive virtual manipulative that I will be using in some of my lessons. It's called Interactive Quadrilaterals, and it's from a website called Math is Fun. There's another page that's kind of similar to it, but as you can see this page, if you go down to the bottom, there's not that much information. The other page has all the properties kind of spelled out already. And I want this to be an inquiry lesson for my students, so I want them to be able to explore, look around, and find those properties for themselves. So basically, this is a little bit like GeoGebra, but it's already programmed and it has constraints on it. So you can see the grid in the background like GeoGebra would have. But you can pick the type of quadrilateral you're looking at, and then you can move the figure however you are able to within the constraints of that parallelogram, or that quadrilateral. So in this case, with any quadrilateral, you can move all of these, and they all work fine. You can move them anywhere, because any quadrilateral doesn't really have particular properties about it, besides having 4 sides. But one of the cool things you can do is you can see the angles if you hit the angle button. And so here you can see that they're all different, but in some of these they'll all be the same. You can see the side lengths. So if you move this, they all change. And if you go to a right angle, let's see if I can get one here. There. So if you have a right angle, it turns into that right angle corner, so it's easy to see. You can also put diagonals in. So you can see whether they are perpendicular or kind of what they look like. You don't really see the lengths of the diagonals or the angles in between them, which I think would be a really cool thing for students to be able to have, so I do wish that this program would have that. So I'm going to take the diagonals off because they're kind of confusing, but we can look through the rest of this. So if you go to parallelogram, now when you move it, you can only move it within the constraints of a parallelogram. So wherever you move something to, the other side is going to follow because those sides need to stay parallel. And you can see now that both of the sides are congruent, and then the angles, the opposite angles are congruent, and the adjacent angles are supplementary. They add up to 180. And the students will have a chart that they'll be filling out during this, or a table, and so they'll be able to say, oh, and then observe